All right, y'all, we've got two extension topics today. So we are going to extend our knowledge on two topics that we've already covered. So go ahead and write down 3.6 notes. Higher order, so HO stands for higher order implicit differentiation, and disguised derivatives. That's what we're going over today. 3.6 notes, higher order implicit differentiation, and disguised derivatives. Okay, so when finding higher order derivatives, that just means like second derivatives or third derivatives, just more than the first derivative. Be sure to solve for dy dx before finding the second derivative or the higher derivative. The subsequent derivatives, or like the next derivatives that you find, will have a dy dx term. For each of these terms, you can make a substitution to be able to put your final derivative in terms of x and y. Okay, so moral of the story, first solve for dy dx, then find the higher derivative. That makes sense, right? First thing we got to find is the first derivative. Okay, so write down this example, get this example down in your notes, and let's go ahead and do it. So the first thing we're going to do is find the first derivative of this function. So I'm going to write that as we're going to do the derivative with respect to x of this whole thing, cosine y equals x. Okay, and now we take the derivative with respect to x of both sides. So the derivative of cosine y is negative sine y, except remember, we're taking the derivative with respect to x and we have a y term. So what do we need to multiply by? Dy dx equals the derivative of x. I need to take the derivative of the right hand side. The derivative of x with respect to x is just 1. Okay, cool. Now we need to isolate dy dx. So let's go ahead and get this dy dx alone. We are going to, remember, we're multiplying this sign, negative sine y. So we're going to divide. So we get dy dx equals 1 over negative sine of y. All right, cool. That's the first derivative. That is dy dx. Sweet. Now, let's go ahead and take the derivative of this. So we're going to take the derivative of this whole thing to find the second derivative. So let me do that here. We're going to take, the derivative with respect to x of dy dx equals, I'm going to move the negative out in front, negative 1 over sine y. Okay, and then really quick, y'all, we're going to take the derivative of this side. Let's rewrite it to make it look like something we know how to take the derivative of. So let's go ahead and write, okay, we're actually taking the derivative with respect to x of dy dx equals negative, and this is sine of y to the negative 1, right? The exponent is negative 1 because it's in the denominator and it has an exponent of 1. Okay, and now let's take that derivative. So if I take the derivative with respect to x of dy dx, I'm just going to get d squared y dx squared. That just means second derivative. So d squared y dx squared equals, all right, we're going to use the power rule to take the derivative of this thing, but time out. We have an inside function and an outside function. So we're going to define u and v. So let me go ahead and do a chain rule. I'll do it over here. U equals my inside function, sine y, and then v equals my outside function. V is negative u to the negative 1. V equals negative u to the negative 1. Now, let's kind of go off on this side tangent, take these derivatives with respect to x. Remember, so we're taking the derivative of sine with respect to x. That's going to be cosine y times dy dx. And then we need to take the derivative of negative u to the negative 1. That's going to be, the negative 1 comes out in front, turns positive u to the negative 2, which remember, u originally was sine y, so we have sine y to the negative 2. Okay, so that derivative, that chain rule piece, remember you multiply the derivative of u times the derivative of v to get that chain rule piece. So we are going to say this second derivative equals cosine y times dy dx times sine, I was considering moving this to the denominator right now, but we won't, times sine of y to the negative 2. Okay, so now let's go ahead and move the sine to the denominator. So we get equals cosine y over sine squared, or sine of y squared, and then times dy dx. Now, this is where it gets kind of weird. Didn't we find dy dx somewhere? Didn't we find dy dx somewhere? Over here, y'all. Look, dy dx. So we're going to now plug in for dy dx. So we have equals, actually, and we're going to plug in for two things. So instead of making you write more, I'm just going to show you what else we're going to plug in for. We also have cosine y. This cosine y, what was the same as cosine y? This was sneaky. Cosine y equals x. So we're going to plug that in as well. So I'll highlight that for y'all. Let's see. Cosine y equals x. We're putting x here. Cool. And then we'll be done. So we have x over sine squared y. Remember, I can write it like that. I can take that 2 and put it in the middle to represent sine of y squared, times dy dx was 1. I'll do this in pink. 1 over, because that's what dy dx was in, sine of y, negative sine of y. And if we put it all together, simplify, we have d squared y dx squared equals negative x over sine cubed of y, or sine of y cubed, sorry. All right, and that's our final answer. Second derivative, higher order, differentiation of implicit functions. Okay, we have one more example to do for notes. We're going to do a disguised derivatives example. Okay, so recognizing derivatives in disguise. Recognizing derivatives in disguise. You may recognize this limit notation. We have the limit as h is going to 0, and then we have 3 plus h on the inside. We're dividing by h. What does that limit look like? It should make you think of the limit definition of the derivative. So let me write this down. Limit definition of derivative, and you should write this down too. We have f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, cool. So if the AP exam asks you to find this limit, it looks like a derivative. It is a derivative. You do not actually have to find the limit. You don't have to substitute in 0 or simplify or expand. This means take the derivative. So this actually just means take the derivative. We have to figure out, take the derivative of what? Of f of x at the specific x value. So we're trying to take the derivative of f of x at the specific x value given. Okay, the things we have to find are f of x and the x value. Oops, sorry, let me do that in a different color. We have to find f of x and we need to find the x value. So how do we do that? Here's how I do that. Think about in this equation, where is x plugged in? So let's go over here. Where is x plugged in? Well, x is right here. I also see it right here, and I see it right here. So x should be the easiest thing to find. Our x value is right there and right there. Our x value is 3. So let's write that down. X equals 3. So we have we have one of the pieces that we need to find. Now we need to figure out what is f of x. So where should we be looking for f of x? Well, y'all, this function is f of x, this whole thing. So let's go ahead and write that down. Let's look right here. F of x is this. F of x equals 8 times 3 cubed. Oh, and sorry, it's not f of x here, right? It's f of 3 because they plugged in 3. Now, this one is actually extra tricky because that doesn't help us that much. So let me really quick write down also what f of x plus h is. So look, f of x plus h sits right here. So that would be right here, right? F of x is 3, right? So it would be 3 plus h equals, and then we have 8, 3 plus h cubed. Okay, and this one's extra tricky because we have to figure out which 3 is the x being plugged into. And the easiest way to think about it is you're plugging x in to, like here, again, this is x. So they plugged 3 into those two places, so that blue 3 should actually be here. So what is my function? What is my function f of x? This means f of x equals, well, let's replace the 3 with an x. Let's change this 3 right here to be an x instead. So we have 8x cubed. That's your function, y'all. This is it. F of x is 8x cubed. So we know f of x is 8x cubed, and we know that x equals 3. So what is this question asking you to find? This question, put it together. This question is asking you to find the derivative f prime of 3. First step, find f prime of x. F prime of x equals, use the power rule, 24x squared. Second step, plug in 3. F prime of 3 equals 24 3 squared, which equals, we are going to just write down this, but it is 216. That is the answer to this question. The derivative at x equals 3. That's what this limit is asking for. It's the derivative of f of x at x equals 3. Okay, I know that seems like a lot, but like once you get more practice with it, you'll be able to recognize f of x, the function, and the x value that they plugged in a lot faster. So let's practice.